All right, this morning let's discuss weight types, um, and this time we're going to look at async I/O completed. In this case, the first place that I would start looking at would be the disk perfmon measures to spot any unusual behavior, as well as cross-checking with everything else that involves the disk system. As a case in point, the computer that I'm currently on, it's an old computer and it has disk definitely issues now. And if I were to compare a like environment on a newer computer, newer disk, it's going to be a lot faster. And so in general, there's going to be a lot of bottlenecks related to my disk because it's an older disk. It's just not as fast, and there will come a day that it crashes. For sure. So comparing a test environment that has different hardware behind the scenes, that way you can process of elimination. If it's the same issue, then it could be more related to the architecture, which is the next thing, is to look at the architecture that directly impacts the system with heavy reads when this may be less necessary. Also, is the system using the most efficient design? A good example of this is recently I looked at a system that was using a lot of non-clustered and clustered indexes, and there was a lot of indexes that didn't need to exist. Remember, in newer systems, if you have access to the clustered column store index, that may be more appropriate to use, and then you don't have all of those other indexes that you have to maintain. And in my experience, the clustered column store index is a lot easier, a lot simpler to maintain, and then of course you're looking at more efficient storage not only on the disk but also in memory, and that's going to drastically reduce the amount of disk usage when you look at systems that use that. Okay. Digging further, of course, evaluate cached query plans and identify queries inefficiently using indexes or not even using indexes, like when they're using heaps. Check the system design, including but not limited to, of course, the SAN network, etc., along with what transactions may be crossing these. There are situations in which it can be impacted by other things that are occurring that are using, of course, the disk system, and that may be creating a bottleneck, right? So wherever the bottleneck is going to be, that's where you're going to want to identify. But when you look at, first of all, try to eliminate the possibility that it's a hardware issue. And by the way, that's a good example of comparing it to a test environment that has different hardware, and then you compare it to, or you look at your architecture and evaluate whether maybe that's what's happening behind the scenes. Generally, what I've seen is that this is most impacted by less than efficient hardware. And so, I'm sorry, not less than efficient hardware, less than efficient query design. Hardware has been a couple of issues, and like the current system that I'm on is a good example of where I will see this, and that's because it's an older disk. It will fail someday. It's not quite as fast as the newer computers that I have, and I can compare that side by side. Again, I can do things like a backup and see how fast does the same database run here and here, and then what are the type of things that are happening on the disk perfmon measures.